Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. It's a standard Algebra 2 question, but it's kind of a violent situation where somebody's throwing a poor bird in the air and then watching it hit the ground. But we'll ignore the violence and just focus on the math. I think this is best done with a sketch, and here we have a time. And here we have the height of the poor bird. So when time is 0, you can see the bird is at 4. So somebody threw this bird up in the air from a height of 4 feet. And then you can see that this is the equation of a parabola. It's a second-degree equation, t squared. And so you know the parabola opens down because of this leading 0. So to sketch the graph, we know that it looks something like this. And this is when the poor bird hits the ground. Okay, so the first question, what's the maximum height of the bird? So we're going to do that here. And the x value is negative b over 2a. That's a formula you should remember. So it's going to be negative 75 over negative 32. 2 times 16 is 32. And this is going to give me 2 and 1/3, or 2.3 repeating. And then we just find h of 2.3, plug that into the equation up top. And I did this on my calculator. The calculator's giving me 91.9. So that's the coordinate of the vertex. So this would be 2.3 is the axis of symmetry here. X equals 2.3. Let me just redraw this. So at 2.3 seconds, the bird reaches its maximum height, and that maximum height is roughly 91.9 feet. Height is in feet. Time is in seconds. Okay. Now the bird is going to go through the vertex here, and then it's going to hit the ground hard. So that's kind of sad, but there it is. We want to know that time. So to find that time, we just set the height to 0. So you would just say negative 16 t squared plus 75t plus 4 equals 0. And you would have to use quadratic formula to get the answer. And I'm assuming you can do that. And but I'm going to calculate the answer. Use my calculator to find the answer. And just take a second to do that. Unfortunately, this quadratic does not factor, and you'll have to use quadratic formula. So I'm getting on my calculator, I'm getting that t is going to be 4.74 seconds. So here 4.74 seconds. And then for part C, we just have to figure out when the bird is 75 feet in the air. So we're going to set the height equal to negative 16 t squared plus 75 t plus 4 equals 75. And then you'd bring the 75 over, you're going to get negative 16t squared plus 75t minus 71 equals 0. And you'd have to use quadratic formula again to find the answer. Let me switch colors. When is the height of the bird going to be at 75 feet? We already know that the poor bird was at 91.9 feet when it was at the height of its travel. And now we want to know when it's going to be at 75 feet. So we're interested in these 2 points. Once again, you would have to set this up. If you wanted to do this by hand, you would have to do it using quadratic formula. Much easier to do this on a calculator, so that's what I'm going to do now. And I'll give you the answers so that you can check your work later. So the first one I get here is 1.3 1.32 comma 75, and then the other point that I get, just give me a second, my calculator, is 3.37 comma 75. So this point here is going to be at 1.32, and then this point here is going to be at 3.37. And so those are your answers. I really think the hardest part of this problem is all the calculation, especially if you're required to do it by hand, is you have to use quadratic formula for B and C. And even for part A, you have to plug an uncomfortable value 2.3 into that height equation, which is a nuisance as well. But anyway, this is a classic question. This is called Newton's formula. Sir Isaac Newton discovered this and formula, and it's you'll see it over and over again. So you need to be comfortable working with these parabolas and these types of questions. You'll see them throughout high school, and you'll see them sometimes, occasionally see them on a SAT or ACT exam. Okay, so I hope that was helpful to you, and I'll see you again next time. Bye-bye.